All right, so guys, today it's day 39, and we're gonna talk about 3.4, which is how we're gonna prove that lines are parallel. Your homework is up here. It's page 164, numbers 8 to 15, and 18 to 23. Don't forget to grab a sheet of paper from the front of the room. You're gonna need it. Okay, so yesterday we learned about 3 types of angles that were found between parallel lines. And hopefully you guys remember that those types of angles were corresponding angles, and same side interior angles, and alternate interior angles. Okay. Yesterday we basically talked about as theorems, and we would say, for example, with the corresponding angle theorem, if 2 lines cut by a transversal are parallel, then corresponding angles are congruent. And based of your knowledge from logic, you know that we can take the converse of that statement by switching the hypothesis and the conclusion, right? So we can take the conclusion, and make it the new hypothesis. And we can take the old hypothesis and make it the new conclusion. All right. This theorem is just like the corresponding angle theorem that said 2 lines cut by a transversal, then corresponding angles are congruent. Except now it gives us something else. It says if we have 2 lines that are angles that are corresponding and they're congruent, then the lines themselves have to be parallel. This is how we are going to prove that lines are parallel. We would refer to this theorem by the converse. We will literally say the converse of the corresponding angles postulate. If 2 lines are cut by a transversal in such a way that the corresponding angles are congruent, then the lines are parallel. And here we have example 2. It's on your paper. We have 2 lines. We have angles 1 and angles 2 marked. Angle 1, they're telling us, is 64 degrees. Angle 2, they're telling us, are 64 degrees. And they want us to make a conclusion about lines L and M. All right, since we have 64 and 64, angles 1 and 2, and they represent what should be corresponding angles, and they are congruent, that means L is parallel to M. Okay. Which is exactly what we have right here. We have a pair of corresponding angles. They are congruent, and as a result, what can we conclude? N is parallel to M. That's all by the converse of the corresponding angles postulate. All right, that wasn't the only postulate we learned. We learned about alternate interior angles, and alternate interior angles are supposed to be congruent as well. So if we have parallel lines, K and J, if we have that this angle and this angle are congruent, and they are a pair of alternate interior angles, if they are congruent, then the 2 lines must be parallel. So that makes line K parallel to line J. All right, next one. Same side interior angle theorem. The same side interior angle theorem said if we have same side interior angles, then they would be supplementary. So the converse allows us to say if we have a pair of supplementary angles, like how angle 1, the measure of angle 1, let me erase that. The measure of angle 1 plus the measure of angle 2, if it adds up to 180, if they are supplementary, then we can conclude that A is parallel to B. All right. What theorem does this conclusion use? So here we have 2 lines. We know that this angle is right and this angle is right, which means they are congruent to one another. What pair of angles does this look like? Well, it looks like a pair of corresponding angles to me. So basically, by the converse of the corresponding angle theorem, we can say that R has to be parallel to S because our corresponding angles are congruent. All right. Here we have the converse of the same side interior angles theorem. two lines cut by a transversal such a way that same side interior angles are supplementary, then the two lines are parallel. And we're basically going to use that right here to prove that the two lines are parallel. So here we have that angle 1 and angle 2 are supplementary, and that's what we are given. And we want to prove that L1 is parallel to L2. Okay, so we're going to fill in this proof together. Angle 1 and angle 2 are supplementary. That was given to us. Angle 1 plus angle 2 equals 180. And why do we know that? Well, that's what supplementary means. So basically, I'm going to say that that is the definition of supplementary. Right? Okay, angle 1 and angle 3 are 180. Let's look up here, 1 and 3. What do angle 1 and 3 form? Well, they form a line, so that definitely means they add up to 180. So that's because they are a linear pair. All right, now we're going to take these first two statements and somehow combine them to make this next statement. Well, this one equals 180. This one equals 180. So I can replace the 180 in the first equation with what 180 equals in the second equation. This is the substitution property. All right, let's look at our equation right here. What have we done to get from this equation to the next one? Well, they both hit angle 1, so it's like we subtracted angle 1 from both sides. All right, since angle 2 and angle 3 are congruent, why does that make L1 congruent to L2? Well, that's because angle 2 and angle 3 look like their corresponding angles. So by the converse of the corresponding angles theorem, we know that line 1 is parallel to line 2. All right, here is your homework. The answers to your homework. Feel free to pause this if you need to check them over. All right, at this point in time, the back of your worksheet has a ton of classwork on it. If you could please do the classwork, make sure that you have it done in case I ask you to hand it in tomorrow. And I will see you tomorrow.